joined. This is the first in a 4-part renewable natural gas series that we're doing and sponsored by EPA AgStar. We're really excited about this series. This is all about what are the opportunities for a farm, any type of farm in the renewable natural gas space. And today specifically, we're here to answer, will renewable natural gas work for your specific farm? You may be on the line at a farm that's considered renewable natural gas, or maybe have had conversations about it. Potentially you've been approached by a developer in the space, and you might have some additional questions that you want to learn about. So we're here today on this first part in the series just to talk about, will this work for your farm? What are some of the questions you might need to ask in order to determine if you would be a good fit for this opportunity? So before we get started, just a reminder that this opportunity in this space right now is really, really prime for agriculture. As we talk about agriculture in the sustainability space, we have to remember that each of you who has a farm, you're such an amazing environmental solution, and what you're able to do on your farm is really powerful in this space right now, right? You're able to reduce, kind of cut your waste and reduce your greenhouse gases, and at the same time, through this opportunity, produce clean energy. So we really think of it as kind of a double benefit and a value that farms can bring to communities across the US. But when we talk about sustainability today, we definitely don't want to leave out the fact that when you talk about this, you also need a revenue stream coming in. You can't talk about one without the other. And today we're going to also talk about what does that revenue stream look like, and where's the market going in this space to determine if it might be a good opportunity. So throughout the webinar, I encourage you to ask questions. There should be a Q&A chat at the bottom of your screen. If you think of a question as we're working through the presenters, please feel free to type that in. We do plan to save majority of the questions for the end. And like with any of our webinars, if we do not get to the questions, we will be sure to kind of type them up and send them out afterwards with the recording. So we want to make sure that we get all of your questions answered today. So what will we cover today? Just how to plan for successful projects to help you better understand what's driving the opportunity in this space and what does it look like short-term, long-term. What type of information, as you consider it from a farm perspective, do you need to collect? This includes cow numbers, cow cooling numbers. What are some of those numbers that you need to start to think about and collect from a farm perspective so you can prepare for this opportunity? We'll walk through some of the digesters that your farms could consider. And then the big question is, what are the risks and rewards of undertaking a project like this? We are very lucky enough to have Nick from EPA AgStar on the phone. And again, they are a sponsor of this webinar and an incredibly important partner in this space. They've put together some really impressive resources that we use on a daily basis, but also farms can use to help them navigate this somewhat complex space. So I will turn it over to Nick, who's just going to give a couple of minutes about EPA AgStar and the resources that they have for farms. And then we'll move into talking about some of the content today.
Wonderful. Thanks, Jamie. We're really pleased to be here today and to be partnering with Nutrient to put on this webinar. And you've assembled a great team of experts in this space, including Keith Henn and his team at Tetra Tech, who have helped us over the years to put together a number of the resources that AgStar has available on our website, and which I'll share with you in just a moment. So a little bit of background on AgStar. We're a partnership program at the U.S. Environmental Protection Agency. We work very closely with the U.S. Department of Agriculture, and our whole goal is to help farms implement sustainable practices for managing their manure. Primarily, that's been helping to share information and best practices on anaerobic digester technology and the end uses, including that of renewable natural gas. We work really closely with livestock producers, non-governmental organizations, state government agencies, and universities to help share those best practices and get more digesters and more sustainable practices implemented on farms. And just this last slide, quickly just wanted to share with you the wealth of resources that the EPA AgStar program has available for free for you all on the call to take advantage of and utilize to better understand anaerobic digesters and to help guide you through the process of thinking, are these systems right for your farm, and all the different considerations that go into understanding these systems, from our biogas toolkit, which is a web-based toolkit that has 36 tools and resources that can help you with project development. And then those other 4 underneath there, the project development handbook and operator guidebook, are both incredibly useful to help walk through considerations for developing the project and operating them. Keith Henn, who's our speaker today, and his team at Tetra Tech help us develop both of those resources, and they've been well received and have the project development handbook has actually over 8,000 downloads since its publication last year. So really pleased to be getting that resource out there, and a number of other resources, one of which, the bottom one there, the Anaerobic Digester screening tool, we just launched last week. And that's a pre-screening tool where you can evaluate how much biogas can be produced from various feedstocks. It's as simple as putting in the amount of manure or waste you have, and it can produce a biogas estimate and how much emissions can be reduced from your farm from that waste. So we look forward to continuing to collaborate with Nutrient and with all of you. We have a hotline if anybody has questions or needs assistance, and that's what we're here for at EPA AgStar. So I'll turn it over to you, Jamie, and thank you very much for partnering with us on this.
All right, awesome. So why is this topic so important to us as Nutrient? You'll hear from Mark Storman, who also works for Nutrient, in just a little bit, but this is a company that represents farms across the country. And our goal is to help farms identify how they can reduce their environmental footprint in the most economically viable way. And we always say that first part is easy, right? We have technologies, we have solutions. It's the economic gap that we need to help close through markets and through opportunities like we're talking about today. And when we really think about the work that we do, it touches across the farm. Today, we're focused on kind of this manure handling and nutrient management piece, which is a big part of the farm's footprint. But any of the solutions that we look at really touch across the entire farm to address and reduce the farm's greenhouse gas footprint. But not only that, we know that there are market opportunities and revenue generating opportunities in each of these spaces. So we're really focused on how can we help bring those and make those markets more accessible for farms. So if we leave you with anything today, know that both Nick and his team at EPA AgStar and Nutrient are here to provide a service to you as a farm and kind of help you navigate these different opportunities that we're now seeing in the sustainability space. So now let's dive into specifically renewable natural gas. I will turn it over to Mark Storman, who will provide a nice overview of where the market is today and where it's going.
Thanks, Jamie. As we look across the country at the different places where there's anaerobic digesters and biogas systems in the United States, it's a very interesting distribution, and it's interesting because the digesters are where the animals are, but compared to some of the other countries that have adopted renewable energy practices, the number of digesters that we have, just under 300 in agriculture, is virtually insignificant compared to the opportunities that are out there. And as we look at the reasons for that, some of the key reasons are the prices of fuel and energy in the United States. And so you might be asking yourself, well, what's really driving these renewable energy projects if we haven't had more than 300 over the years that digesters have been around, and they've been around for quite a while? What is it that really is driving these now? And I think if we look at the next map, you can see that it's really being driven out of the West. Right now, there's a low carbon fuel standard program in the West that adds a lot of value to renewable natural gas that gets into the transportation sector in California, Oregon, and Washington. Those 3 states have passed low carbon fuel standards. The California one is the most lucrative from a sales standpoint and the one that is moving along the fastest and led the way. But these type of programs are also being considered in other parts of the country. And so as we see more and more of these low carbon fuel standard programs being adopted, as we see national programs like the Renewable Fuel Standard, the RFS program, and as we see more and more customers that are demanding accountability and sustainability from the people that make their products, once again, as Jamie said, dairy farmers have an opportunity to be a solution and a significant solution to some of these environmental problems. As I mentioned, there are kind of a coalition along the west coast of the country. And on the next slide, we'll just take a quick look at that. It's called the Pacific Coast Collaborative. It's a regional agreement between Oregon, Washington, and British Columbia, as well as California. They strategically are aligning. They're putting LCFS programs in place that all pretty much resemble each other. And those markets are going to continue on, and they're going to continue to grow the demand for renewable natural gas. Because of that, we now have an opportunity to see the value increase. And if you look at the next slide, you'll see that these programs over the past few years have all started to increase in the price. The price of, according to the low carbon fuel standard, has been really at or very near the $200 mark for the last 3 years, as the RIN pricing has increased and decreased, but in the last year or so has, kind of rebounded. And as we now see natural gas prices go up, it makes it more and more attractive for those farms that can produce renewable natural gas to get it into the pipeline and to actually be able to have a revenue generating project. There are a lot of those projects underway. And as we look at the next slide, you'll see that there are a lot of companies that have announced that they've signed agreements with dairy RNG projects. That does not mean that those projects are all necessarily in operation. And so we see that there have been announcements for about 160 different dairies to be involved, but up to this point, only a couple of those are actually producing renewable natural gas. And because most of those were brand new, not all of those have CI scores. And a CI score is a carbon intensity score. It's how the value is assigned to a project. And we're going to go deeper into what that will, what's involved in that later on in the program. But first, let's look at what it takes to scale a project or these projects and these renewable energy projects. On the next slide, we kind of list some of the things that are really causing these projects to scale up. And those state incentives like the LCFS certainly are part of that. The national incentives are part of that. There are a lot of companies around the world that are setting aggressive carbon reduction goals. Some of those companies are in the EU, but they actually have facilities here in the United States. And so their reductions here in the United States count against their corporate goals there. Other companies that have their headquarters here in the United States are setting goals strictly driven by their consumers demanding that they have some sort of accountability for their environmental footprint. And then as we continue to look beyond that, we see gas and electrical utilities that are looking to get more and more renewable energy on their portfolio. And electrical utilities can get that through wind and solar, but for gas utilities, it's much more difficult. There are less direct replacements for natural gas outside of possibly using some of the renewable electricity to generate hydrogen. Everything else has to be pretty much generated by either anaerobic digestion or landfills. And then last, but certainly not least, if you're one of the people involved, we've seen increased regulations. And so as we see regulations come down and regulations get tighter, we have more and more incentives in different parts of the country to put renewable energy projects in place. We believe, and one of the things that we continue to work at Nutrient, is an opportunity to create long-term established markets. Because once you get a long-term market in place that can pay for a project and that can pay for what a project produces, then you have an opportunity to start a business case around it, and you have an opportunity to diversify the revenue from your farm. And so what we're going to be talking about and looking at are the upcoming opportunities that you have to join in established markets like the ones in California and the ones that are being passed. And then as we go farther in this series of webinars, we'll also touch on the additional opportunities that may be coming long-term. Now I'm going to hand it off to Keith, and Keith comes to us from Tetra Tech. We have had the opportunity to work with them and EPA AgStar in the past. And so as we're going to dig in a little bit more into content that you will find in the Digester Handbook at EPA, we're going to turn it over to Keith to give us an overview.
And thank you, Mark. Thank you, Nick and Jamie, for inviting me to join. So a little bit about myself. I've been in the business since about 2007 with about just shy of 30 years of experience overall. And Mark nailed it with his description. This is an opportunity. And in order to embrace that opportunity, we really have to understand a little bit about the market and how the farm can benefit from this. It really always starts from the farm. So if you can move to the next slide, I'll start off with many of these things, by the way, are in the project development handbook, as Nick and Mark just mentioned. And so I'm going to talk a little bit about those things and how to understand this opportunity. And it'll be a great dovetail off of what Mark just described. So first off, in the handbook, we try to bring this down. It's a very complex set of systems that have to be worked together. And so we try to bring it down to a couple or 10 exactly keys to digester success. First is a plan. These are complex. They're not commonly understood. So you have to plan for success. You have to identify goals and work and define those goals, both for the farm and for this new venture, as Mark pointed out. Then you've got to put together a team that has experience. This is a key component because there are a number of folks out there that work on projects like these, but they may or may not have that experience that you're really looking for and that you can trust. So it's combining and developing a very core team. It's developing a sustainable business model. And of course, that is a financial model, and that financial model has to work well with the farm and the farm operations. As Mark pointed out, and he will point out in the subsequent slides, this is a different type of business and a different type of opportunity. And so you really have to understand how that works in terms of financial as well as the operational business model. So the next segment here is kind of talking about it. Once you've developed these core pieces, then it's really understanding what we call feedstock. In the farm, it's manure, it's waste product, but it's really a feedstock. It's the foundation of a bioenergy and an RNG project on farm. So understanding that understanding the chemical, physical, and volumetric characteristics of feedstock supply is very important. Then, only then you can choose the right technology to convert that feedstock or manure into biogas and thus into energy. So, or RNG specifically. So it's looking at the right technology that matches the feedstock, not the other way around. So the next step is optimizing your options for that biogas. Once you generate that biogas, how do you best monetize that gas to benefit the farm and this new venture operation? And that could be a number of different things. RNG is the primary focus today, as Mark pointed out, and he will explain why. But there are other reasons, there are other options for this biogas that may be and are evolving in the marketplace. Then, of course, the use of digestate, which is a byproduct of the digester. It's the liquids and the solids that come out of the digester. How can one use those beneficially? Then follow on that is how those offtakes or the agreement between you as the owner of that material and the seller or I should say the buyer of those offtakes, whether it be the RNG or it be digestate, compost, or otherwise. It's developing sound agreements with those partners. Next section here. So once you do that, you have to understand and quantify those benefits. There are more than just financial benefits. For example, a digestion has a very positive impact to odor, meaning it'll eliminate or reduce that odor on the farm. It may have other benefits to the operations of the farm in terms of nutrient management and how one can utilize the digester to assist those agricultural options. The next piece of this is making sure you communicate with the community. This is a key component. And then finally, plan for the long-term operation and maintenance of these projects. Next slide, please. So what is a digester? It really is broken down into 3 simple components. This graphic illustrates the many components, but let's just break it down into simple. It's the feedstock, in this case, manure on the top. That feedstock is then converted into the second step, which is an anaerobic digester. This is a very conventional technology. As Mark mentioned, this has been around for years, in fact, thousands of years. It's a very well understood process. So that's the second step, the conversion process. The third step, if you will, is the gas or the products that are generated and how one monetizes those gas. How does one transfer that asset into the marketplace to get revenue from it, whether it be the biogas in the form of RNG, let's say on the bottom left, or in the bottom right, it might be digestate, utilized for animal bedding or organic fertilizer or crop irrigation. These are the 3 primary components, the front, the middle, and the back, if you will. And each one of those have a very unique set of skills that are required to put all these together into an integrated system. Next slide, please. So let's talk about where this all starts. Well, frankly, very pleased to have this presentation, this opportunity, because it really starts with the farm. It's understanding the farm operations, how the manure is collected, how much manure, how is it transferred, how is it currently being managed, and then how would an RNG or a digester and RNG project fit into that farm operation. So it starts with the farm. Not all technologies are going to be the right solution for any given farm. So it really is very farm centric. We got to look at the specifics of the farm and how to integrate this idea and new venture into that farm operation. It certainly can produce additional revenue streams, making it economically viable, but it may not be all for all farms, both from a financial standpoint, operational standpoint, and a business standpoint. So it's necessary to really look at these things. In the next couple of slides, I'll be talking a little bit about different technologies. And if you could just put it back to that last slide, one of the things that Nutrien has identified here is nutrient recognized technologies and an understanding of these from a very high level. So you can understand what various technologies are there and what are their benefits, if you will, peer review benefits that have been documented, as well as expert opinion. So that on the right-hand side, you'll see from the nutrient need matrix. Next slide, please. So I'm going to talk about the very broad different categories of digesters. There's lots of different variants, but I'm going to simplify it for you all in that there are really 3 basic categories that are most commonly implemented on farms. First off is the covered lagoon. It's basically most farms or a lot of farms have lagoons. This is essentially and simplistically covering that and capturing the gas that would otherwise be emitted into the atmosphere. And so this is the lowest tech, if you will. You can see the characteristics on the left-hand side of the slide on what it best is served, the type of situation it best serves. And this is probably the most common situation across the world. In the United States, you can see there's approximately 75 operating today. Next slide. The next common category is a mixed plug flow, conventionally referred to as a plug flow, but it's been modified as referred to as a mixed plug flow. A graphic or a picture on the bottom center, you can see. And there's a number of these, approximately 80 of these are US farm-based systems that are in operation today. You can see the characteristics that this mixed plug flow system can best perform under and the type of situation. Next slide. And the third, and probably in a worldwide, most commonly applied is a complete mix or a continuous stir tank reactor. Here, this graphic illustrates a round tank. It can be concrete, can be steel, and it has an inflatable roof on the top. That roof, if you will, is basically the biogas that's generated from within the tank and goes up and is captured in this roof. It's used for storage as well as conveyance to its use. You can see that there are about 95 of these operating today in the United States, but across the world there are thousands, 8,000 in Germany, I believe, on last count, official count, but there are tens of thousands around the world. This is the most common digester that's utilized across the world for farm-based systems. Next.
One quick question before you move on. Someone asked in the Q&A, is anyone commercially selling liquid or digestate for peat moss replacement? I thought the byproduct material needed to be light and fluffy, similar to peat.
That's correct. Yes. Well, the answer is yes, but we have to break that question down a little bit, because from the digester comes digestate. That is a combination of liquids and solids. When the liquids and solids are separated, the solids can be further managed and composted, and can ultimately be sold as peat moss, or a substitute, if you will, of peat moss. So it's digestate. It's commonly found at your grocery Lowe's or Home Depot type of stores, where you can find these types of things there. So this is, generally speaking, it is referred to as peat moss, but it's certainly not. It's a replacement. So it can be a soil amendment. It can be a compost amendment. It can be composted and used for agricultural purposes in that manner. So there is that opportunity, and it's commonly done. The liquids, on the other hand, can be utilized for other purposes. And I think there was a mention there about nutrients. So of course, the nutrients can be removed from this digestate with an additional set of technologies to have utilized that for quantitative and sale use. So the answer is yes, but this is a subset of reducing that digestate into additional saleable products, if you will.
Okay, one more question. Is the
Sure.
hydraulic retention time a function of reactor type and design, or the substrate? If it is the function of a substrate, why is it listed within the designs?
Excellent. Well, it is a function of both. So it's a function of the type of digester, the type of feedstock that goes into that digester, and of course, the amount of biogas that you would want to get out of that. In order to determine that hydraulic retention time, oftentimes what's done is laboratory testing to look at that specific feedstock, determine its biochemical methane potential in a laboratory, and we can estimate how long one would want to have a hydraulic retention time of that media. Then the actual technology itself can be looked at in terms of fine tuning that hydraulic retention time for that specific case. And yes, you can see that each one of these generalizations that I've had on these last 3 slides essentially show different hydraulic retention times depending on feedstock and the digester technology itself. So the answer is yes.
Awesome. We have a few more questions coming in on the types of digesters, but I want to move on to make sure we can get to some of the other information for everyone. So we will regroup at the end to try to answer those. And if not, we will type them up and get them to everyone following the webinar.
Excellent. So this next slide is talking about the opportunities and benefits. And we've tried to simplify this so that we can get the key points across, but there is a number of benefits of digesters: socio-political benefits, greenhouse gas mitigation, there's odor benefits, there's farm operational benefits. But these ones here are probably the most important ones that are essentially driving the marketplace, as Mark pointed out earlier. So the energy benefit, the biogas, which is about approximately 55% methane, and the balance of that is other impurities, that can be converted over to energy. So that is the primary point, as Mark pointed out. The environmental credits, these attributes, if you will, they're commonly referred to. Mark has introduced these two. These are driving the monetary value of the biogas that is then used in the industry. Carbon credits and renewable energy have certainly been around for some time. And so there's a number of subsets of those environmental credits and environmental attributes. Of course, as I mentioned before here, both in the QA as well as in the illustration, the compost and bedding materials that can be generated from digestate is certainly a value. And then if one were to use co-substrates, which means manure plus other organic substrates, such as organic fraction of solid waste or food waste that is non-consumable, fog or fats, oil, and greases, these are co-substrates, then one can receive a tipping fee to receive those and process those in the digester. So these are the primary financial drivers, if you will, of anaerobic digestion on farm. Next slide, please. So biogas from all these types of feedstocks vary. First off, from dairy cattle and hog manure, you can see that at the bottom of the scale. So on a volumetric basis, there is less amount of biomethane, biogas specifically, and biomethane generated from these types of feedstocks. But the point here, they vary from the feedstock to feedstock. So all types of manure, dairy, hog, and in some cases poultry and others are conducive to anaerobic digestion processes, but there are of course different feedstocks which require different applications of those conversions. So it's very specific it would be necessary to look at each of those types of feedstocks. So the biogas yield, while low, comparatively speaking to these other types of materials, while low, has a methane avoidance. Therefore, it has a high monetary value, as Mark pointed out with the CI and the LCFS and the RFS. So while it's a low volume producer, it's a high quality and quantity from a monetary standpoint. And not all biogas and RNG is equal in value, as I think we'll talk a little bit about in the subsequent slides. Next slide, please. So on-farm considerations for these types of things, it's really starts from the farm, and it starts about how the manure is recovered and how is it managed currently on the farm, how that may change going forward. Is the digestate used as bedding on the farm, or are there other types of bedding materials? Labor, permitting, schedule, and traffic, and odor. These are all things that are going to be important to input into this plan that we talked about, this plan for success and the goals. These are all really important considerations for one to consider whether or not they want a digester on farm. There's also future considerations such as the succession plan, the expansion plan. Is it going to, the farm size going to contract or grow in terms of number of head, which then translates to the amount of manure? So these are all very important things to consider when you're looking at an RNG or digester / RNG project on your farm. Next slide. Then, of course, there's other considerations that is very important to the farm, and that is understanding your costs of operation today, specifically the cost to collect, transfer, and store and dispose of the manure today, and then how will that change positively or negatively going forward with the inclusion of a digester and RNG system. Or a genset or electrical generation really doesn't matter. What's key is understanding those costs today and how will that change going forward. And what is the value of this manure as pointed out in terms of the digestate? Once the biogas is generated, it's either taken off farm for sale. The manure that's left over, which again is that digestate, can it be used for a fertilizer? Can it be used for bedding in place of another type of bedding? Are there tip fees and so forth? So there's financial and operational considerations that are very important to consider when you look at a project like these. Next slide. I believe it's back to you.
Back to Mark.
Thank you, Keith. What I want to cover now over the next couple of minutes is just a little bit to help you understand what the financial opportunities might be and how those are calculated. So as you look at the opportunity for a digester and deciding whether a digester or a renewable natural gas project is right for your farm, you have some understanding of what the economics are being driven by. And primarily, we're going to talk a little bit about carbon intensity scores. One of the real reasons that you as dairy farmers are being approached to do these projects is the very low carbon intensity that is resulting from your project. And many different projects can produce RNG. Many of them produce it in a way that produces a beneficial fuel, but not all of them avoid the same number of emissions as a dairy project does, because the CI score is calculated not only just on the fuel that is replaced, but also the emissions that are replaced. And so we're going to take a quick look at how these different revenue streams fit together so you can see what the value of the renewable natural gas is. And then we're going to take a few minutes and just quickly, give you a couple of examples on some of the things like Keith mentioned, that you need to look at. For example, how would you look at your manure handling costs and those sort of things. So if we go to the next slide, you'll see that, and this was all updated on September 27th. So it's a couple of weeks old. The prices are all a little bit higher right now, but when you're being paid for renewable natural gas, you're actually going to get potentially 2 or 3 revenue streams from the gas itself. The first one is just a base gas price. And so this is looking at an average of the futures on the CME group. And we look out 3 years just to kind of take out the spikes. And right now, or at the end of September, natural gas itself was valued at about $3.90 per million BTUs, MMBTU. And that is how gas is priced. So the cumulative of that is $3.90. When the next set of credits that you can get is under the renewable fuel standards, and you can get a credit called a RIN, a renewable identification number. A RIN has a value depending on what feedstock is used to produce that renewable fuel. And in the case of manure, it's defined as a D3 designated cellulosic RIN. If you have food waste, it's a D5 RIN. And when you blend the two feedstocks, you have a very difficult time right now, the way that it's being required to show that differentiation. So generally, projects that are mixing the two, all of the RINs are considered D5, unless they're doing an extensive amount of testing. And so many of the dairy projects that you'll see are only doing manure as part of their digester feedstock. But that RIN is worth its value for 77,000 BTUs, an ethanol gallon equivalent. So that means 1 million BTUs is actually worth a multiple of that. And in the prices on the 27th of September, the RINs were actually worth $34.57 per million BTUs. And so if you were just selling into a transportation market in the United States outside of California, you could get $38.47 per MMBTU, which is almost 10 times the value of natural gas itself. The last piece that we get into, and where we get into the CI scores, is part of the low carbon fuel standard. And we'll talk a little bit more about how the CI score is calculated, but currently an average Midwestern anaerobic digester that's using a heated digester replacing an open lagoon will have a CI score of about a -250. Many of the earlier digesters that came into the LCFS program have a score around that. That 250 then is converted, depending on the fuel that's used and depending on the credit, the credit is $161. And then using that CI score and a calculator produced by the California Air Resource Board, we find out that that credit is worth $50.11 per MMBTU. So essentially, by selling into the low carbon fuel standard in California, you're increasing the value of that million BTUs from $3.90 to almost 23 times that, $88.59. And looking at the numbers today, it's closer to $93 an MMBTU. How that's important is each cow can produce about 21 MMBTUs per year. And so as you're looking at doing projects, and as you're looking at the opportunity to work potentially with developers or doing your own project, you have to make some decisions. That 21 MMBTUs is based on normal operations and a heated digester. So of the 3 digesters that Keith described earlier in the program, covered lagoons typically are not heated and certainly are not heated to 105 degrees Fahrenheit. That means that they typically need a longer hydraulic detention time. And even with that longer hydraulic detention time over the course of a year, will produce less gas. Both the plug flow digesters, mixed plug flow digesters, and the covered or the complete mix or CSTRs are typically heated to either mesophilic temperatures or thermophilic temperatures. And because they're heated, they can produce more gas and they can produce that gas all year round. And these numbers are based on a heated digester. So 21 MMBTUs are what you could expect to get from per cow per year out of a heated mesophilic digester. And so you can see that there's a significant return on the value of a project. So the value of the RNG from a single cow is close to $1,867 using the numbers above. And so that's an important thing to remember as you're looking at the opportunities that you have to either build digesters or to partner with somebody to put a digester on your facility, because it gives you a reference point to work with them to create a good project where everyone's gonna be compensated and everyone gets their fair share of the value of that product. As we look at what determines that CI value, we start to see that there are several things, but number one is whether or not you separate the solids before you put them into the digester. If you separate the solids before you put it into the digester, it's going to change the score because it's going to change the volume of the gas produced. And it can, how you handle those solids can result in additional emissions that you are not capturing. So your CI score might not be as high if you're not capturing the emissions off those solids in the digester. So you might be wondering, why would you ever capture those solids? Well, certain digesters, for example, covered lagoons, are much more difficult to clean out. So the more solids that you get in that don't break down, the less opportunity, the greater opportunity there is for your digesters to start filling with solids. The other thing is the farm design. How are you collecting your manure? Are you scraping it? Are you flushing it with water? Are you storing it in a pit that gets a crust over it that keeps it from emitting? Or is it stored in an open, fairly fluid state where, air and wind can keep it agitating and constantly be releasing emissions? That's another consideration that goes into the CI score. Frequency of cleaning the lagoons. Some areas clean their lagoons very frequently. They're emptying them twice a year. Because they do that, they emit less greenhouse gas. And therefore their CI score actually goes down because they're not contributing as much of a problem. The goal of the LCFS is to really reduce those impacts that are producing the most methane emission. So as we look at that, the other things that you get are the type of cows. A Jersey cow is smaller than a Holstein cow, producing less manure, so there would be less gas production. The type of bedding that you're using and what you have to do to separate that bedding if you do separate it. And then there are also some other considerations. So we're going to take a look at just two side-by-side examples, very, very simplified, in the next slide. One is illustrative of a CI calculation that would be close to what we just have been using, that minus 250. We're going to get to a 210. And that's by looking at a anaerobic digester where all the manure was just pushed into a lagoon, and the lagoon was not cleaned out regularly. So it only was cleaned out when it had to be. In that particular case, because it continues to emit, because there's always material in the lagoon to kind of seed and start that methane production, even when they're pumping it down somewhat, the avoided methane emissions from a project there would be a minus 325 megajoules. And so what we per megajoule produced. So what we then do from that 325 is we have to look at how much carbon emissions are going to be required from the energy that's needed to produce that. So we're going to need to heat that digester somehow. If we're using natural gas, then that may take 50 megajoules to produce a megajoule of energy. And so that has to be subtracted. And then you have to take the emissions and the fuel emissions from a vehicle that's using that. And so that emission has to be subtracted from those avoided emissions. And that in this case is about 65 per megajoule. And so once you do the subtractions, or the additions in this case, you end up with a minus 200 CI score. And so the revenue there would be something like, I'm not sure what the date was when they did that. I don't think they're using the same data, but in this case, for example, $81. If you were to just separate your fiber and put your manure into a lagoon, but you were to continually be cleaning and emptying that lagoon before you put in the digester system, the methane emissions would be considerably lower. And so you'd start out with a minus 130, and then you would still have to add the carbon emissions from heating that material, and that would be the same relatively if the volume was close to the same, and the tailpipe emissions would be the same. And so you can see that the CI score for that project would be considerably lower. Here in this case, about having, dramatically reducing, almost wiping out the CI score halves the revenue that you would get for the gas that you produce. Now, because it halves it, even though the score is almost completely reduced to zero, you do not have a situation where you can just look at the CI score and automatically assume what your revenue stream is going to be. And so when you start to look at these projects, it's very important to get an understanding of what the revenue of the project could be based on a preliminary CI score. And those are things that you can get either working with developers, working with your own engineers, or by contacting Nutrient, we can try to help you identify where you could get that CI score and how you could go about making that decision. The last thing we'd like to touch on is just very quickly a couple of slides comparing the annual manure costs for a theoretical 350 cow dairy. And the first one we're just going to look at real quickly is a daily spread operation. Somebody who's taken the manure out, spreading it like my uncle used to on the farm every day, and getting it incorporated as quickly as we can. I'm not going to go through all of the calculations. They're there so you can take a look at them, and you can spend a little bit more time reviewing them if you want to. But in this particular instance, using these numbers, we end up with about $1 per hundredweight as the manure cost for this 350 cow dairy, or just about $269 per cow per year. Another example on the next slide is if you take that same 350 cow and did a scrape to a lagoon. So people might be asking, well, why don't we just stop using lagoon? 350 cows, same volume of manure being scraped, but now a significant amount, probably 2/3 to 3/4 of the material can be sent out through pivots. Doesn't have to be hauled to the field each day. It produces more greenhouse gas, but you can see it significantly lowers the cost to the producer. And so what we're trying to do here, is show that here you have about a 77 cents per hundredweight of milk produced, or about $202 per cow. So that reduction explains why you see a lot more lagoon systems, and those lagoon systems have a bigger greenhouse gas impact, and those lagoon systems therefore have a bigger advantage, changing a better CI score, lower number, as they change over and look at a renewable natural gas project. The last thing I'd like to do is kind of leave you with some questions and things to consider as we get ready to move forward into our questions and asking and looking at what people have been putting in the question and answer. Certainly, if you have any other questions, go ahead and put those in there. But see, these are some of the things that we will try to be answering, and you should be considering as we look at the next 3 upcoming webinars. First of all, are you committed to a long-term business relationship? Building an AD system and entering into a renewable natural gas project is probably a 20-year commitment. And the people that you're going to partner with, whether you're doing it yourself on your dairy or whether you're partnering with a developer, are going to want to know things about that long-term relationship. Things like, what's your succession plan, as Keith mentioned earlier? And the people that are going to succeed you on the dairy, do they agree with doing a project that lasts this long? The other thing, as you look at whether you're going to do a project or whether you're going to partner with someone else, is what is your risk tolerance? Are you willing to risk capital, and are you willing to risk markets that might be very changeable? Or would you rather partner with someone else to take more of the financial risk? And if you are, how are you going to compensate them for the financial risk that they're taking? Another question you should be asking yourself is, will this project affect other parts of my operation? And what parts of my operation, and what will it do? Having a digester on the farm, what kind of traffic is it going to change? What are the things that we will need to do differently on the farm? And then as you look at the actual project itself, what kind of expertise do you as a dairy farmer have to draw on for this type of a project? I often ask dairymen if they're ready to start a new business in the energy field, because that's what a project like this is. It's truly a new business venture where you're producing renewable energy. And if you don't have the expertise or the partners to do that, as Keith mentioned, that right team around you, it can be a very, very difficult and a very disappointing endeavor. Those are going to lead you to questions to things like, who's going to own the project? You may want to put all the money in and see as much return as possible. You may want to put no money in and see a fair return for just supplying feedstock. Next, we go to who manages the project. And a lot of times people don't realize that you can own something without managing it at all. So you could also outsource much of the management of a project, even though you owned it. And then who will operate the project? And the illustration that I give all dairymen as I talk to them about doing projects like this is, if you're operating the project and the digester goes down at the same time the feed wagon goes down, which one are you going to fit for? Which one are you going to fix first? In all likelihood, you're going to make sure those cows are getting fed, and that means your digester is going to be down. So very often it's an advantage to have someone whose sole responsibility is keeping the digester running. And then finally, in light of all of those other questions, who's going to be responsible if there are any environmental issues? Or if there is a situation where something goes wrong, how are you going to handle your manure if the digester is not operating? Who's going to be responsible for that? Who's going to be responsible for if something spills or if something's not stored correctly? Make sure you have considered some of those questions, and we're going to try to help answer some of those questions as we move forward in this webinar series.
All right, thanks so much, Mark. I'm going to jump right into questions and we'll go right back to you. A quick one. Are substrates permitted under this RNG program? Can you clarify that?
Yes, substrates are allowed under the renewable fuel standard and under the low carbon fuel standard. So yes, you can use substrates. They change the value of the gas produced. Under the renewable fuel standard, instead of getting a D3 RIN, you'll get a D5 RIN. Typically, about 50% of the value. Under the low carbon fuel standard, it's going to change your CI score. A typical CI score, if you looked at that, is somewhere between 0 and 50 for a food waste project, closer to minus 200 to 250 for a manure project. So yes, they're allowed, but the revenue is significantly increased if you do manure only.
And then to kind of add on to that question, is there any movement on the RIN forefront to reverse the financial penalties for generating D5 versus D3 RINs?
I don't know if there's any movement. I know there is a lot of activity and a lot of work being done. There is an organization out of Washington, D.C. called the American Biogas Council that has put a proposal before EPA, and that is regularly meeting with them to try to get them to simplify the division of D5 and D3 so that there's an opportunity for dairies to maximize the gas production and the benefit to society of using waste. But at this point, I do not believe that there's been any change in the position. And so there are a lot of people that are hoping that that change is made, but we don't have that opportunity right now.
All right, another quick one. Does a covered lagoon digester produce the same quality of digestate as a complete mix unit, same odor, pathogen reduction, etc.?
That's a very good question. And because no two digesters are the same, I'm going to have to speak in generalities. Typically for a covered lagoon, you separate many of the solids beforehand so that the digestate is not going to remove the pathogens. It's not going to have the same heat value, and it's not going to have the same digestate because, number one, it's not the same material going into a covered lagoon as coming out of the covered lagoon. Again, there are probably covered lagoons that don't operate that way, but I'm talking in generalities. Number two, because the temperature isn't elevated, you're not changing the bacterial mix as much. You're just kind of letting, giving it time for the bacteria that are already there to continue the digestion that came out of the cow. And so you get less of a pathogen kill when you're using a covered lagoon, but at the same time, you're typically not reusing the solids and things like that from a covered lagoon as bedding. So it's not necessarily as big of a negative.
Great. Okay, another question for kind of anyone who wants to take this one, but a good question. As farms start to feel and are under immense economic pressure and don't necessarily maybe have the operating costs or the capital costs to invest in a project like this, what can they do to foster collaborative, cooperative projects, potentially among a group of smaller farms, or identifying partners to kind of help move some of this work forward?
I'll make an attempt at this, and it's a great question because it's really a question of, how can we involve farms of all sizes? And there is definitely an opportunity to bring together multiple farms to feed a digester. And I think as we see more incentives and as we see more opportunities, we'll see a different different economics and different things play out. I visited years ago, I visited Reeb, Denmark, where they brought together the manure from 100 small farms to power a digester and to supply the heat and energy to the town of Reeb, Denmark. They do central heating in Europe. And so because of that, they were able to gather the manure, take it to the digester, and then return the digestate back to the farms. And so they were always running manure back and forth. And that same model is operating today in a few places in the United States. One of them is in Tillamook, Oregon. It's not a very popular model. One of the reasons is it's not always a very good idea to put manure on wheels and to haul it up and down the highway. If you follow the news stories on manure that come across the internet, you will see that very often accidents and things like that can happen when you have manure on wheels. And so as you look at those opportunities, how you transport it and all of the costs that go into it can significantly affect whether or not you can bring together a group of farms.
Mark, if I could just add to that, I would agree with everything you said. Economies of scale matters. There's no question about that. The larger projects have better economies of scale. But I think Mark's point is also very good. As this market has changed, and it's changed considerably in the last 3 years, as it has definitely in the last 20 years. Things change, and there's additional opportunity. It's unfortunately, Mark was also correct in that we have to speak about generalities, because no farm, no digesters from one project to the next. So it's very specific in its nature. So the economies of scale may be necessary on one particular type of farm, but it may not be in another area. There's lots and lots of factors. How close is one farm to another? How much liquid is it with that manure? Are they adjacent properties or are they separated? How is that manure being transferred from truck or pipe from point A to point B. So these things can happen. The economics are improving with the things that we presented in this slide. I guess I wanted to hit on another spin-off to that point. There's a lot of folks that are interested in doing these projects, as no doubt the press releases, as indicated in this presentation, as well as others, have suggested. So that energy, that excitement into these projects then brings investors into the marketplace. They see this, and those also help overall. But again, it's going to be very important to look at a farm by farm basis. Unfortunately, that's just the fact of the nature of the matter here.
All right, I would love to get through the rest of the 20 plus questions that we have. As promised at the beginning, we will type these up and get the responses to you with the recording in the next week or so. Just wanted to call out a few additional things. If you do have more questions or want to talk with someone, no matter what point you are in this process of trying to figure out, does your farm fit this opportunity, please reach out to us at Nutrient. Our information is here. You can respond to the email we'll send you with the recording. Secondly, we just started to scratch the surface on this topic. We could probably have 30 webinars talking about the opportunity around RNG. But next time, we're really looking forward to start looking at how do you start to choose what the best potentially business model might be for your farm if you're interested in wanting to pursue further. So please consider joining that. And we have a few more coming up. Again, EPA AgStar is a great resource. Visit their website. As Nick mentioned at the beginning, they just launched a new tool as well. So we'll talk more about that in future webinars. And again, if you would like to reach out to any of us, please do so. Thank you for joining today.